All right, guys, so I am out today, but I wanted to make sure that we had the notes covered because we do have a test next week. So let me, do not disturb, good deal. All right, notes are on the back table in case you didn't get them. The picture is from last time, so it's just a reminder that our central angles and their arcs are always going to be equal. You'll notice that the red one is 125 and the arc that is made between the two endpoints there is 125 degrees also. And just a reminder that an inscribed angle is inside of the triangle, right? Excuse me. We have two formulas. We have arc length here, and then we have finding radians there, okay? Easiest way to get through this is just going to be to go ahead and do these examples and go from there. And when it's needed, I'll show you how to use them in Desmos. But generally speaking, most of it I think you can probably figure out on your own with Desmos, but I'll show you. All right, so it says encircle J. Remember that this is the center of my circle. With the measure of minor arc HK equals 36, so out here I have 36. And we want to find our angle right in here, okay? We want that angle right there. So easiest way to do this is I have half of my arc HK is going to be equal to the measure of my angle HLK. And I'm just going to plug in what I know. So what I know is that HK is 36, so I have half 36. Half of 36 is going to be 18. So the measure of my angle HLK is going to be 18. So if I have the arc and I want the angle, then I'm going to divide by 2. Okay, so if I have the arc and I want the angle, I'm going to divide the arc by 2. All right, next page. Sorry. I was doing good till I started this. All right, so it says encircle L with measure of angle KLM is 60. We want to find the minor arc. So I want this out here. They told me that this in here was 60. And you got to remember, we had two kinds of angles. We had inscribed angles, we had central angles. Central angles come out of the center of the triangle. Well, L is the center of my triangle. My angle is coming out of that. So this is a central angle. And if my angle is 60, that means that my arc has to be 60 also, because central angles and their arcs are equal. And it's, we want to try to remember that because it's easier than doing a whole lot of work down the line that we don't need to do if we can just remember that central angles and their arcs are the same. Okay. Number 3, again, I have circle Q and I have angle PQR coming out of it at 120 degrees. This again is a central angle. We're looking for the arc. So my arc is 120 degrees also. Number 4 is kind of like number 1. It tells me that my angle in here, so that part right there, is 24 degrees. And we're looking for the arc. The difference now is they're backwards, right? First on number 1, I had the arc, I needed the angle. This time I have the angle and I need the arc. So I need 2 of those angles to equal my arc. So 2 times 24. So my arc is 48. Well, there you go. Okay, that's PR. All right, number 5. Number 5 is going to throw some algebra at us. With the algebra, I'm not necessarily wanting you to be able to show me that you remember how to solve a two-step equation. Next year in Algebra 2, you will need to be reminded of how to solve a two-step equation. But for right now, for our practical purposes, I want to know that you can set it up, put it in Desmos and know what you're getting out of Desmos, okay? So I'm going to draw my picture. There's my center. It's telling me that my center is at T because it's telling me circle T. So it says the measure of arc US is 64 degrees. Solve for x if the angle is 8x minus 49. And we want to round to the nearest tenth. All of them on this page, we will round to the nearest tenth. Notice that I have a T in my angle. That means that I have a central angle. So my arc is 64. This out here is going to be 8x minus 49. So the measure of my arc has to equal the measure of my angle. My arc is 64 degrees. My angle is 8x minus 49. I have no idea what is on my Google, but we'll get there. Desmos, oops, nope. Desmos, well, I'm just messing that all up. Desmos graphing. Do not get the one that says testing. We are not trying to test anything, right? We don't want to test. We're past testing. We don't ever want to do testing again. So don't get the one that's in testing mode. Testing mode is the one with the green banner at the top. Make sure it's a black banner like the one that I have. So I'm putting this into Desmos. 64 is equal to 8x minus 49. Nope. 49. And what we're looking for is where it crosses the x-axis. So I'm coming over here. I click on the little dot. If I ever end up with something in the y spot, I've done something wrong, okay? So I have x is equal to 14.125, and we are going to the nearest tenth. So then you look at the second one. Does that 2 round the 1? Nope, it doesn't, so it's 14.1. All right, number 6, drawing my circle again. Told me the center was at C. Notice here in my angle there is not a C. Okay, so that's telling me that I have an inscribed angle. So there's my inscribed angle. They tell me that my angle is 50 and my arc is 7x plus 40. Okay, so this was like on the first 4, or 1 and 4 rather, I guess I should say. If I have 2 of my angles, then that equals the measure of my arc. So 2 of my angles, and there's my arc. So now in Desmos, if you can want to do the mental math, go for it. If you don't want to do the mental math, I'm okay with that too, as long as you type it in correctly. 7x plus 40. Click on the little dot. X is 8.571. Going to the nearest tenth. So does this 7 round that 5? Yes, it does. So I get 8.6. All right, last one. Have my circle. There's the Y. Notice Y is not there again, so I have another inscribed angle. They tell me this time my arc is 130 and that my angle is 9x plus 31. So I have half of my arc is equal to the measure of my angle. So they told me that the arc was 130, and they told me the angle was 9x plus 31. So I have 1/2 times 130. Struggling with my letters today. There we go. Is equal to 9x plus 31. I click on the little dot. x is equal to 3.777. We want to know, does this 7 round that? And it does, so x is 3.8. All right. Number, what did we get? Number 7, number 8. All right, so my formula for this is on the first page. So this is arc length is equal to my central angle all over 360, and I'm multiplying by the circumference. And I'll pull Desmos back up here in a minute. All right. They tell me that the angle here, that part right there, is 42 degrees. They tell me that the side length MN, so this side length right there, is 12. And so I have that, and I'm looking for my arc length. Remember that the 12, the MN, is going to be my radius, which is what we need for circumference, right? So I end up at 42 over 360, parentheses, circumference is 2 pi r, so I have 2 pi, my r is 12. Now let me show you what that looks like in Desmos. When we put this into Desmos, we're going to type it in exactly as is. So I have 42 divided by 360. I'm going to open my parentheses. 2, I'm using the pi button. It's down there at the bottom by the square root because I do not want to round anything yet. I always want to round at the end, so I'm going to use the pi button so that we're not rounding anything. So I have pi, and then my radius was 12. So I have x is 8.796. We're rounding to the nearest hundredth. So the question is, does that 6 round that 9? Well, it does. It rounds it to a 10, which means I'm carrying that 1 over, and I get 8.8. Not writing out the formula again because it's lengthy and I'm running out of room. This time they tell me that my angle here is 66, that my, come on, there we go, whoops. That my side length here this time is going to be 3. And we're still again looking for the arc length. So I have x is equal to 66, my central angle, over 360 times 2 pi 3. So over in Desmos, I'm going to take the 12 off, make that a 3, take the 42 off, make that a 66, and I get that x is 3.455. Does this 5 round that 5? Yes, it does, so 3.46. All right. There we go. Looking at number 10. Couple of things we need to note. S is going to be the arc length. R is the radius. And that little symbol, we call it theta, is the angle. We're treating theta like it's a variable. We're not doing anything with it. We're just moving it around, okay? Our formula is S equals R theta. So we're going to read the problem, fill in what we have. So it says, in a circle with radius 8, an angle intercepts the arc length of, and that's 20 pi, I know it's hard to read, over 3, and we're looking for the angle. If theta is being treated just like it's an x value, then that x value with that 8 is multiplication. The opposite of that is division, but I can't divide a fraction by another fraction. What I can do is multiply by a reciprocal. So any whole number, like my 8, I can make into a fraction by putting a 1 under it. My inverse of that would be 1 over 8. And that allows me to move this 8 out of the way. Anything times 1 is just that number. On the bottom, I get 24. When we put that in Desmos and we simplify, we see that our fraction is 5/6 pi and is equal to theta. We do not put pi into the calculator when we are trying to simplify the fraction. Just the numbers themselves, not the pi part. All right, last one. So I have S is equal to R theta. It says that the angle this time is going to be 2 pi over 3, and it intersects an arc that is 2 pi, and we're looking for our radius. So just like we did above, I have 2 pi over 3. My inverse of that, when I flip it, is 3 over 2 pi. So I have 3, 2 pi. That gets rid of that one. If I have the same thing in both top and bottom of a fraction, then they cancel each other out. So I have a 2 pi in the top, I have a 2 pi in the bottom, they cancel each other out, and my radius is 3. Okay, so use your notes. There is a notes quiz that goes along with this. I will pull grades for that over the weekend, and please make sure also that you get your Delta Math for today done. Thank you much.